don't know me, but I ask a lot of questions. So when I ask you a question, it doesn't mean you're not right, and it doesn't mean you are right. It just means I want to know what you're thinking. So just get used to me asking questions. I also don't ask for raised hands. I will call on you, and I have all your names on these cards. If you don't know, that's okay, right? If you know everything, then you probably should just go up to 6th grade because you don't need to be here. I don't expect you to know everything. You're allowed to pass, right? So if I ask, what is your name, sweetie? If I ask Brindley a question and Brindley says, I'm not sure, I pass, and then, what is your name?
Tristan.
And then Tristan knows, I'm gonna have Brindley listen to Tristan, and then I'm gonna say, so Brindley, what did Tristan say? So you're responsible for listening, right, and participating, but you don't need to know everything, right, because we're still learning. All right, if I call on you to read, and you really don't want to read, you can say, I'd rather not, and I'll call on somebody else. So there's no pressure. I don't like hands because I like to give everybody time to think. And when people see hands in the air, it makes them nervous. Like, oh, Tristan already knows that I'm still thinking, right? I don't want anybody to be nervous, right? We're just gonna have fun. I'm very, very, very laid back, so just relax, we're gonna have fun. All right, learning goals. Since I know Tristan's name, Tristan, would you read the learning goals?
Yes. I can determine the volume of a right rectangular prism with whole numbers, side, length, 5.
Go ahead, you can go up.
Packing it with unit cubes, I can
Generalize.
generalize patterns to identify a formula to determine the volume of a right rectangular prism.
Thank you, Tristan. So a lot of times we read those and they don't make any sense to us. It's like, yeah, we read them, but what the heck does it mean? Basically, we're just gonna look at different ways that we can find volume of rectangular prisms. You've been doing that all along and you already have some ways of doing that. So we're gonna just explore some more. All right, so you don't need your book open yet. Let's see, how about Dylan? Where's Dylan?
Isaiah and Camellia used to calculate the volume of the given prism. Prepare to share what you notice and wonder. Isaiah and Camellia calculated the volume of a rectangular prism.
All right, thank you. So, this is how Isaiah thought about it, and this is how Camilla thought about it. First, I want you to look at Isaiah, think about what he did. So take a moment, just think independently. Let's come back, I'm loving what I'm hearing.
She got the
So first of all, how are they similar? How is what Isaiah and Camilla did? How is it similar? Gracie?
Yeah.
Gracie, go ahead.
They both got the same volume.
What do you mean they both got the same volume?
They both got the same volume of 72 cubic.
They both got 72 cubic units. I can't talk. Okay, 72 cubic units. Any other thing that you see that's similar? Tristan? Did I get that right?
They both
That's all right. You want us to come back?
okay.
All right, we're gonna pass. How about, I got Keely. Where's Keely? What do you think? If you don't have something that's same, is there something different?
They used a different strategy.
Tell me more about that.
Instead of length times they used,
The B times the H. What do you think B? What do you think that B might mean? Think about that. Think about what Isaiah did and look at Camille. What is that B? Remember, I'm not going to call off your hands up. I'm going to pick someone I haven't. How about Jace? Where's Jace? What do you think, Jace?
I think the B stands for like both width and length.
Oh, why do you think that? Tell me more about that.
Because they just times length times width to get 18.
So what over here is making the 18?
6 times 3.
Oh, so you're saying the length times the width? They're just making it a B.
Interesting.
Everybody's attention for just a moment, please. The boys' bathroom, we are allowing the boys to use the urinals. So boys, you guys are using those until we see that they are not being used properly, but for now, I've not gotten any complaints, everything seems good, so good job. Keep that up. Also, we need to keep the door shut. Please shut the boys' bathroom door, gentlemen. You may do this if you see that it is open. And if something happens where we're not using the urinals properly, we'll have to close those up, and then we'll talk about that then. But for now, we're going to keep the door closed, and we're using the urinals correctly. Thank you.
All right, good job, guys. All right. I need you to open your books now to page 28. We're going to think about what this B, right? We kind of think like this length and width together is B, right? It's both. But what does B really mean? I want you to look up. Brains on, hands down. Worked example. I want you to independently, I want you to look at that worked example and think about, what's going on here? Go ahead, take a look at that worked example. What do we think? What do we think about this worked example? Gotta pull out my handy dandy cards here. I already called on Keely. How about Chris? Where's Chris? Chris, what do you think?
I think B stands for bottom.
Oh, you know what? I talked to Jace. He thought B stood for bottom too. Anybody else? Why do you think B stands for bottom? What is your name? Carson, why do you think B stands for bottom?
I'm pretty sure it means the base of the bottom of it and the height of how tall it is. So the volume equals the base of the bottom and the height is the height.
He just said a really important word. It is the bottom, but we have a math word for that. What do you think that math word is? Gracie.
The
Say that word, that B word again.
base.
Base. Can we say that word? Base. Right? So this is volume equals, what's that B? Base times height. So here, we're going to pretend that this is a solid figure, right? And if I want to find the volume of it, what could I do? What could I do to find the volume of this? Talk to your partner. What could I do to find the volume of this? All right. How can we find the volume of this? What do we think? And I left my cards over there. What is your name? Kason, what do we think? Caselin, I'm sorry. What do you think?
You can either do 16 times 6 will get you 96, or you can do 16 6 times.
Oh, so this, I see what you're, isn't this? This is different. So what do you think about this one?
You did look at the length times width, and then times that, and then see how, like, the height of it, and then
Oh, so Caselin said we could look at the length times the width. What's that math word we just learned?
Base.
I heard
Base.
base. I heard an A word. Who said it?
Area.
So how are base and area related? Think about it. How is base and area related? Someone I haven't heard from, I think I've heard from, what's your name? Wyatt, what do you think? How are base and area related? What do you think? Can you show me? If I give you one of these, show me what area is on here.
in the middle.
Oh, the stuff inside, all this inside, right? Do we agree? How many dimensions is area? Do you know what I mean? Give me an example of a dimension if I ask you for a dimension. What am I asking for? What's a dimension, Jace?
A dimension's like 2D or 3D. 3D is like we're a base, and then a 2D is just like area.
So 2D is 2 dimensions. So what are the 2 dimensions if we're finding area? Gracie.
Length and width.
Length and width. Another name for area, if we look at this, is it's what? Base. Times height. So these are Do you recognize these from second grade?
Yeah.
No,
What are these?
I do
It's
not.
a hundreds block, right? So, what's the area of this?
100.
100 what? Hippopotamuses?
Square units.
100 square units. This is our base. So if I stack, how tall is it?
4.
So what is the volume of the whole thing?
400.
400 hippopotamuses.
400 square
400
units.
square units? How did you know that?
'Cause you
100
can-
plus 100 plus 100 plus 100.
So we have our base, right? And we just, we just multiply by our height.
Or you could do the 10 times 4. Is it
So show me. Show me what you're thinking. Hold
like
it up, because you gotta show everybody.
the 10 on this side,
Uh-huh.
and then the base of on the bottom and the area of the middle and the bottom, just times the height of 4 on the corners or anywhere could get 400.
So you're saying, I'm gonna repeat what you said, tell me if I'm right. This 10
Yeah.
times this 10 times that 4,
Yeah.
is that still gonna work?
Yeah.
Does it matter, right? Could we do length times width times height?
It's
Yeah.
because you're
Yeah.
timesing 10 times 10, which equals 100, and then just timesing 100 times 4.
Exactly, all right. So let's keep going. So, I want you to work with your partner, but don't move yet. Your actual partners that you're gonna do for that, we'll do. Work at your table. I want you to just do number 1 and 2. I'm only gonna give you about a minute and a half, so go ahead.
Kylie?
All right, Kylie, tell me about your thinking for this one.
Well, if it's 2 square units up, and it's 12 on the bottom, then both layers are 12, so then that would make you 20.
Oh, I love what you said, both layers are 12. How does she know there's only 2 layers? How does she know there's only 2 layers?
Because right here it says height is 2, so that means like 12 on the bottom base, and then 12 more on the top base because it says 2 right here.
Awesome.
The height?
I love your thinking. All right, how about the next one? Kaysen. Where's Kaysen? Kaysen. What do you think?
I could do times 25 times 4.
Who agrees with Kaysen? Who can add on to why Kaysen thinks that? Tell me your name again. Dylan.
25 times 4 would be, the height is 4, so 25, 25, 25. 25 equal 100 cubic units.
Cubic units. Awesome. All right, I want you to finish. Move. I want you to do.
I got another one. I thought square meters. I'm pretty sure meters is like 3 or 4 foot. So then I just added 3 to 25, and it got me 75. And I just times that by.
Oh, you just thought about, you got the same answer, just a different way. I love that. Thank you for sharing that. All right, so I want you to do 3, 4, 5, and 6 on the next page.
72 times 6.
72 times 6. What do we think? Do we agree with Chris? All right. What did you get for 72 times 6, Chris? 432, right? If you didn't get 432, but you knew that you needed to multiply those, that's okay, right? Because I don't want you to worry about the computation. Miss Smith is going to work on computation. Right now, we're thinking about understanding how we determine volume. All right, so sometimes these are bigger numbers, and we don't want to get bogged down with that. We want to make sure we understand about finding volume. All right, so how about number 4? Wyatt. Where's Wyatt? Wyatt, what'd you do for number 4? Just tell me what you did to figure it out.
Times 45
45 and times
times 9.
9. Do that. Anybody else do that? Jace, no. What do you say? No. What'd you do?
I knew that 5 there's 5 times 9 equals 45, so I did 9 times 9 equals 81, and 81 times 5 to make it easier.
Can Jace do that? What'd you get, Jace?
405.
What'd you get? You didn't finish it. Anybody else get 4 or 5? Gracie, did you get 4 or 5? All right, Ish, 4 or 5. How did he know that it was 9 times 5? How did he think about that base? What do you think? He broke that down. How did he know that? What do you think? What do you think, Tristan?
Well, I think he might have done.
Why didn't he do 8 times 3? He did 9 times 5.
Maybe because it was probably easier to him than doing that.
Oh, so maybe he broke it down because that was easier. Chase, how did you know it was 9 times 5?
Because the width on it, where the not 45, it was as big as the height going up, so I knew it was 9, and I thought, what times 9 equals 45, and I thought 5 times 9 equals 45.
To make it easier. So he used his doubles facts. He likes 9 times 9 is 81. But 9 times 5 is 45, right? We talked about it. We can do length, width, and height, or we can do base times height. You're going to get the same answer.
The board's gonna go up.
Just tap it
Ooh.
real quick.
All right. Sorry. All right. Here's a different one. What do we think about this? What do we think about this, Brindley? You didn't get to that one?
I did. I did 3 times 3. That equals 9 times 10. That's 90.
Oh, all right. 3 times 3 times 10. Anybody else do what Brindley did? Anybody do it differently? What'd you do?
So I times 10 times 3, and then I got 30, and then I times that, then I times the 3 times the 3, which got me 9, and then I took the 0 from the 10 and added it to the 90.
So you got 90? All right. 90 what?
90
90
Cubic units.
Cubic units. We know what our units are feet. So cubic
feet.
feet. They did it 2 different ways. Does it matter what order we do it in? Why not?
Because we'll get the same answer.
What's that property called?
You're getting the same
Flip flop.
Flip-flop. Is there a flip-flop property? I like that.
Well, yeah, it was W.
Well, it kind of makes you think about it, but what's the math term? It begins with a C. What's that math? Gracie.
It's the volume.
Well, that's what we're determining. Commutative property of multiplication. Doesn't matter what order we do it in, right? We're still going to get the same answer. So, how are these two different? Look at those pictures. What information do we have here that's different from that? Talk to your table. Notice this. How are they different? How are they different?
Number 4 shows the base of the cube, and number 5 shows the dimensions of the rectangular prism.
And how many dimensions are in this one? 3 separate ones. Now listen, 3 separate dimensions for this volume. If we want to find this volume, how many dimensions do we have? Think about it.
yards.
How many dimensions do we have here? We said length, width, height. What do we think in here? What do you think, Jace?
Base times.
I think it's just 2 dimensions.
Just 2, which 2?
The 45 and the 9.
So how many dimensions is the 45? What's it made of? Oh, you're telling me the 45 is made in 2 dimensions. What about that? Is that another dimension? So how many total dimensions?
3?
Yeah, we have 3 dimensions in both. This one just looks a little different because this has 2 dimensions showing area. There's still 3 total dimensions for the volume. All right, let's keep moving. We're not going to worry about those 2. So have anybody ever seen something like this?
No.
Oh, yes. So talk to your partner, what do you think that is? A deconstructed cube, any other ideas? What do you think?
It's a flattened cube.
It's
and
a-
the little parts.
Oh, flattened
fold
cube?
together.
Right, there's a name for these things. They're called nets, right? And you're gonna now, I'm gonna ask you the partners that you had yesterday, that Miss Smith put you in, I want you to move and find those partners, and we're gonna work on our next activity. That's okay. So as you're working, we're gonna pass around our, you know when you watch those television shows and they're making food, and they put it in the oven, and then like 3 seconds later, they pull it out, it's already made? That's what we're gonna do with our rectangular prisms. Ta-da! So if you can't make them, that's okay. You guys almost had that perfectly though. All right, so
Nope, we already got it.
here's our rectangular prisms. What I want you to do is I want you to think with your partner, and I'm gonna pass out some cubes. You gotta figure out the volume of this prism. So we're gonna give you some tools, and I want you to think about what we talked about. The base and the height. You can use what we're talking about to determine what's the volume of this. Work with your partner. I'm only going to give you about 4 minutes, and then I'm going to bring you back, and I'm going to be asking you questions. So I checked in with everybody, and unbelievably, everybody, oh, there's my timer, had the same strategy, which was awesome. What was the strategy that everybody used? I'm gonna pick, what is your name? Dylan? You Dylan? Dylan, tell us about what you and, tell me your partner's name. Carson. What did you and Carson do?
We used the blocks to go from one line to the other, and then however many blocks it was how much that measurement was. So like the length was 3, the height was 5, and the width was 7. So then we just multiplied them up.
Cool. And you know what? I know everybody in the room did that because I checked in with everybody. So I'm gonna have another challenge for you. So now, do you think there's a way that we could determine the volume of a different object? We're gonna use cubes now without these centimeter cubes. Do you think?
Yeah.
What could we do? I'm not gonna let you use the cubes this time. What do you think? What are you thinking? Do we have another tool that maybe we could use? Carson, what do you think?
I think we might have like a bigger one of these. Or
Oh, you want to compare. Unfortunately, Magic of Television did not create another one of those. So we don't. But that's a good
We
thought.
could use a roller.
We could use a ruler. I think that's a really good idea.
I was thinking.
So we did centimeter cubes. These are centimeter cubes. And they fit pretty well. So when I hand you out a ruler, I'm going to actually ask Miss Smith, will you pass this up? You have your choice of using inches or centimeters on this ruler. What do you think might be easier to use? What do you think? We want to use inches or do we want to use centimeters? What did we think? Well, up, time out. Whoop, freeze, hands off the rulers. I need your minds. Right, sit on your hands. What are we thinking? Inches or centimeters? Because we all want to do, we're all in this together. What are you thinking?
Centimeters.
Why'd you pick centimeters?
Because if it's a centimeter cube, then we have to do centimeters.
That makes sense, doesn't it? All right, so as you're measuring, we're gonna be walking around. It might have been a hot minute since you've measured with centimeters, right? So we're just gonna make, what are some things you need to remember when you measure?
To put it on the 0.
Put it on the 0, right? All right, so now I want you, before you measure, I want you to picture what you did with A. The first one we did, it was A. This one's called B. I want you to make an estimate. Maybe you can kind of visualize those blocks, those centimeter blocks. I want you to make a prediction of what you think this volume might be before you measure it? What questions do you have? All right, make a prediction before you measure. Miss Smith and I are going to be walking around as you measure. We're going to start right here. Wyatt, right? Wyatt? With Wyatt and Chris, what did you get for B? Are you still working? You're still working, all right. So we're gonna give them a few more minutes to work. Is anybody else still working? All right, so we're gonna let them finish working. I'm gonna talk to them. So what are you thinking? What is that? So that's 5. So this is a cube, so this is 5.
I'm gonna go and do it. What you do, baby? My greatest hope. My mom coming coming. You got any other cameras?
No, not really. We do stuff on Facebook. Yeah, on Wayne County School.
All right. All right. We're going to go around. We're going to come to you guys last while you're doing your computation. And you're going to tell me what you determined the volume of B to be. All right. Ladies, we're going to start here. You're on. What did you determine the volume? 105 what? What was your units? What did you measure it? 105 hypotenuses? Cubic. What was? Did you do inches? Cubic centimeters. So if they say 105 cubic centimeters, what do you guys say?
We said 70.
70? What?
Because the cube is smaller than the rectangle.
Oh, but you didn't measure it yet. That was your guess. Okay, so now that's a great guess. Figure out how close you are. All right, what did you guys get? 125 what? Cubic centimeters. What did you guys get?
125 cubic centimeters.
How about you guys?
6 inches.
You did inches, you rebels. 6 inches? Is that?
No. I did 5 centimeters. I did 5 centimeters.
So I'm hearing one dimension here. How many dimensions do we need for volume?
3.
3. So is it 5 centimeters?
I think it is 8 inches.
8 inches. What? Just 8 inches? How many dimensions do we have for volume?
3.
So we have inches, inches, inches. How many inches is that? We'll talk about it. What do you guys think? 100 cubic centimeters. All right. So
Yeah.
we got some different thinking here. I heard. Okay, where's the little? Here we go. I heard 105 cubic centimeters. I heard 105 cubic centimeters. How many centimeters did you measure for your width?
100.
How many centimeters did you measure for your width, Gracie?
5.
5.
5.
What? What kind of figure is this?
Cube.
A cube. What do we know about cubes? What do we know about cubes?
They all have the same dimension.
They all sides have the same dimensions. So if this is 5 centimeters, then what's our other? What's that?
5.
Okay, so length is 5, width is 5. So what would our height be?
5.
Oh, how many dimensions is that? 3 dimensions, right? We need 3 dimensions. We have length, width, height. So now thinking, could we do that base thing? What if we do that base thing? What if we do base times height? We do base times height. What's our base? Tristan, what's our base?
The base would be 25.
How did you get that, Tristan?
Because 5 times 5 times 5 is 25.
5 times 5 is?
25.
So, and how many dimensions was that?
2.
2.
Sorry.
Right? So when we do area, we have 25 centimeters cubed. That's 2 dimensions. And we need to times it by the height. What's the height?
5.
What's 25 times 5?
125.
Yep.
So let's think. 425. So we have 4 quarters. How much is that? $1. And then how many more quarters do we have? One more. So $1 is how many cents? 100 cents. And then we have another quarter. How much cents do we have?
125.
125. How many dimensions? 3. 3. If you just told me 125 centimeters, that's not correct. 125 centimeters is we just measured from here out to 125 centimeters. When we have multiple dimensions, we have to make sure that we annotate it correctly, right? The base has 2 dimensions. That's where that 2 comes from. Centimeters times centimeters is centimeters squared. This is centimeters times centimeters times centimeters. That's where those numbers come from. All right, we're going to do the reflection, which I have to look at my notes because I don't know what page that is. All right, so before you start this, I want you to, let's go back to our learning goals. We were going to think about different ways to determine volume. Talk to your partner, what's a different way you learned today to determine volume? Go ahead and do that very, very quietly. Talk to your partner, what's something you learned about volume today? What did you learn today? What did you learn?
That B needs base, not both.
B needs base, not both. Can someone add on to this base thing? What about base, Gracie?
We learned that base is the length times the width.
We learned that base is the length times the width. Can we add on to that? Tristan? No, Carson.
We learned that the base is it's the bottom of the thing, and the height is how tall it is.
Awesome. Jace.
Base is also equal to an area.
Base is also equal to an area. So can we use base to find volume? How? Someone different. How do we find base to find volume? How do we find base to find the volume? How do we use that? It's okay if you don't know. You can pass. That's fine. Who can help? What are we thinking?
The base to, can I?
Go ahead.
Base, how to determine the volume? Base to, that is, so like this, you've got 16 square units for your base. You've got to keep on timing that until you fill up it.
Fill it up. And what do we call that fill up? What's that called?
Square units.
Well, what's that dimension called?
Oh, it's called the
When you go up?
height.
Nice. I loved how you said square units for the base. All right. High five your partner. You guys were awesome. Thank you for letting me come in today.
You're welcome.